Okay, this is a video response to a question I got from Matthew, and I figured that the response that I would give him is beneficial for you all. We see up here the question that was posed. It says on question number 2, part A, we're asked to find the speed of a car at t equals 0.2 seconds. And this is the question down here, and this is the point in question right here. Why is the change in time according to your answer key 0.1 seconds? And Matthew says that he assumed it to be 0.2 seconds using the final time to be 0.2 seconds and an initial time of 0 over here. Okay, so this is, you can't use t equals 0 to 0.2 seconds to do this question. And the thing that you need to pick up on in the question itself is down here at the bottom it says find the speed of the car at t equals 0.2 seconds, and the operative word you're looking for is at. Okay, that's a really important word. When they want the speed at a location, that means they want the instantaneous speed. So if you've been watching through the videos and progressed to this point where you know what instantaneous speed or velocity is, then you know that it's the singular speed that an object had at one particular location and at one particular moment in time. So this question is asking is how fast is this car going when it's right here? Now Matthew, if you use time equals 0 to time 0.2, you have measured over this entire time interval right here. Okay, let's take a look at these dots here for a second, because they're showing us a picture. These dots are all representing a same time interval. So the same amount of time has gone by between each one of these dots, and it's 0.05 seconds. Is that right? No, 0.025 seconds. Okay. So the spacing between the dots is getting bigger, which means from this dot to this dot was the same amount of time as it was from this dot to that dot, but of course right here it covered much more distance than it did over here. Okay, all that to say this: if you use time equals 0 to time equals 0.2, then you are covering a time span through which the speeds are changing. We have a little speed down here and a big speed over here, and if you use an equation that uses this entire time span, what you're going to get is the average speed or the average velocity over this entire interval. But that's not what they asked for. They didn't ask for the average speed over the entire interval. They asked for the speed of the car at this point. So how do you find that? Well, in the truth of the matter is the way we find this is through calculus. We need something called a derivative. But if we don't know how to do a derivative yet, then the next thing that we're going to use is we're going to try to do what you did, find an average, but we don't want to average from the point that they're asking us all the way back to 0. The best we can do is try to average on either side of 0.2. So we might go from this point to this point. Now if we were doing this as a lab, I would actually ask you to measure with a ruler the distances here. But because this is a problem that is posed to you here, they did not give you the distance between this point and this point. So now you're going to have to work with the closest distances you have, both to the right and to the left of this point, and try to find out from that the average speed between those points, which turn out to be this place right here and this place right here. And finding the average between these two will land you at the time that's right halfway between them, which is right here, and we're going to estimate that that was how fast the car was going. Now if you actually do that, your final time over here will be 0.25 seconds. Your initial time will be 0.15 seconds. And then the question is, well, how far has it traveled from here to there? And that is given to us down here. So if we move up here, what you're going to see in the answer key is velocity equals the change in position over the change in the time. Okay, well, your final position here, we don't know what it is. Your initial position, we don't know what it is, but we can tell that the difference is given to us here, and it's 7.5 centimeters. Okay, how much time has gone by? Well, we know that the final time is 0.25 seconds, and the initial time is 0.15 seconds. Okay, here's where the answer to your question comes in then. On the bottom, the time interval here is 0.1 seconds. Running out of room there. And on the top, this is 7.5. Okay, so if you're looking at the answer key, you're going to see 7.5 divided by 0.1. That's where the answer came from, and that's why the time interval is not from the beginning to the last point they asked for, but is measured on either side of the 0.2 second mark. Hope this helps.